Welcome back. So here we will take some other questions on quadratic equations and expressions. So more specifically, we will try to cover some polynomial equations now. So find the roots alpha, beta, gamma of x cubed minus 11x square plus 36x minus 36 equal to 0 if 2 by beta is equal to 1 by alpha plus 1 by gamma. Now here some condition has been given and we are supposed to use that condition to find the roots. We can anyway find the roots by a simple factorization or some other trial and error method. But since the condition has been given, we will try that to use it. Okay. Now 2 by beta is equal to 1 by alpha plus 1 by gamma. That gives us 2 by beta is equal to alpha plus gamma by alpha gamma. Cross multiplication gives us 2 alpha gamma is equal to alpha beta plus beta gamma. Right? Now let's try to write the all the relations of the roots of the equation. Sum of the roots gives us alpha plus beta plus gamma is equal to 11. Remember, it's all alternate signs, so it's minus of minus 11. This is 11. Then we have alpha beta plus beta gamma plus gamma alpha is equal to now it's positive, so it's 36. And finally, alpha beta gamma is equal to minus of minus 36. That gives us 36. Now let's see. We have a condition here. Alpha beta plus beta gamma is equal to 2 alpha gamma. So let's put this in the second equation, and we have alpha beta plus beta gamma is equal to 2 alpha gamma. That gives us alpha gamma is equal to 12. Right? So let's put this in the third equation, and we have beta is equal to 3. Right? 36 by 12, that's 3. And now let's put this in the first equation. Right? So we have alpha plus gamma is equal to 11 minus 3, that is 8. Right? So we have now two relations with alpha and gamma. That is alpha gamma equal to 12 and alpha plus gamma is equal to 8. So alpha gamma is equal to that is 8. And alpha gamma is equal to 12. A simple guesswork here or even hard and fast calculation also will give you anyway the result that alpha is equal to 2 and gamma is equal to 6, right? 2 plus 6 is 8 and 2 into 6 is 12. Hence the roots are 2, 3, 6. Right? So we see that again the relation of the roots helps us a lot in finding the required thing in the question. Fine. The next question now. In a triangle PQR, angle R is equal to pi by 2. Tan P by 2 and tan Q by 2 are the roots of the equation ax square plus bx plus c equal to 0. Show that a plus b minus c equal to 0. Now, this is a classic question where the quadratic equation has been merged with trigonometry. So, hence you must know or you must be fully aware of most of the important identities of all the parts of mathematics. Right? So, now angle R is equal to pi by 2. That gives us angle Q plus angle P, that is equal to pi by 2, or angle P plus angle Q by 2 is equal to pi by 4. Right? Now we know that again applying the sum of the roots, we have tan P by 2 plus tan Q by 2 is equal to minus B by A. Right? Similarly, tan P by 2, tan Q by 2 is equal to C by A. Right? Now let's apply the addition of angles formulae. So let's write down P by 2. Tan of P by 2 plus Q by 2. This is tan of P by 2 plus tan of Q by 2 by 1 minus tan P by 2 tan Q by 2. Right? But we now know all the expressions regarding these, right? First of all, the left hand side is tan of P plus Q by 2 but we know that p plus q by 2 is pi by 4, and we know that tan of pi by 4 is 1, right? At the same time, we also know the expressions for all the things in right hand side. So the numerator becomes just minus b by a, whereas the denominator becomes 1 minus c by a, right? So we have 1 minus c by a is equal to minus b by a. Multiplying throughout by a gives us a minus c equal to minus b, and just transposing to the other side gives us a minus b equal to c equal to 0. Right? Hence proven. Now, here we see that just knowing the formula helped us a lot. Otherwise, it would have been way more tough if we didn't know this addition formula. Right? So, let's go to the next question. This question says, if the roots of x cube plus px squared plus qx plus r equal to 0 are in GP, find the relation between p, q and r. This is a very general question. Usually one of these questions does come from polynomial expressions, because this GP or AP, usually the GP one comes. But anyway, so I'll write the equations in a slightly different way now. I'll write them as a by k, a and ak. Right? Had it been quadratic equation, I would have written as a and ak. But here I'll write a by k and a and ak. Right? So let's write down all the formulas here. So the sum of the roots gives us a by k plus a plus ak minus p. Taking a common, we have 1 by k plus 1 plus k equal to minus p, right? Similarly, let's write down for the sum of two roots taken at a time. So it is a squared by k, a squared k, and then a squared equal to q. Well, that gives us again 1 by k plus 2 plus 1 equal to p. Right? Now, we see that we have this k, we can now remove k from these equations, right? So taking the dividing one equation by another, we have a square by a is equal to q by minus p, or a equal to minus q by p. Fine? Now let's write down the third equation. The third equation is a by k into a into ak is equal to minus r. Now this was the reason why I wrote the equations in this format, so that I can simply cancel off k here. Right? So I have a cube is equal to minus r. But what is a? A is, we have found out a to be equal to minus q by p. So this is minus q cube by p cube is equal to minus r. Or I get rp cube is equal to p cube. Hence, this is the condition for the roots to be in a geometric progression. Okay. Now let's go to the next one. Okay, so solve 1 less than equal to 3x square minus 7x plus 8 by x square plus 1 less than equal to 2. Okay. So for this kind of question, these kind of inequality questions do regularly come in the exams. Now we have to consider both the parts of the inequality. Since it's a double inequality here, we have to consider both of them individually. So let's take the first one, the left hand side first. That gives us 3x square minus 7x plus 8 is greater than equal to x square plus 1. And that means 2x square minus 7x plus 7 is greater than equal to 0. Right? So let's just multiply the whole thing by 2, so that to complete the square. So I have 4x square minus 14x plus 14 is greater than equal to 0. Right? Okay, so this is 2x. Now I can write this as 2x. The second term will be 2 into 2x into something, right? That is 4x into 7 by 2. Right? So let's just try to expand this and see. First one is 4x squared, fine. The next will be 2 into 2x plus 4x into 7 by 2. That gives us minus 14x plus 7 by 2 squared plus, it's minus here because we are already adding one term here. It is minus greater than equal to 0. Now, let's look at this. 14 minus 7 squared by 4. The 7 squared is 49 by 4 and 49 by 4 is, so 14 into 4 is 56. So I have 7 by 4. Right? 14 minus 49 by 4 gives us 56 minus 49 by 4, which is 7 by 4. So we see that the left hand side is always greater than 0 because we have a square and a positive term. So this is always greater than 0. So this is valid for all x. Hence, whatever we get from this second expression must be the range, the domain of x, right? So let's look at the next inequality now. That is 3x square minus 7x plus 8 is equal to 2 times x square plus 1. That is x square minus 7x plus 6 is equal to 0. Or x squared minus x minus 6x plus 6 is equal to 0. Taking it x minus 1 minus 6 times x minus 1, or x minus 6 and x minus 1 is equal to 0. Right? So when will this expression have a value less than equal to 0? We know that the roots are 1 and 6, and hence whenever the value is between them, so one of the terms will be positive, the other will be negative, and hence the value will be less than 0. Hence the domain of x is, or x belongs to the domain 1, 6. Right? So this is the answer. Since for the above inequality, for the left hand side inequality, it was valid for all x. Hence the intersection is only this part, and x must belong to 1 to 6. Okay, so the next one. So if alpha, beta and gamma are roots of the equation x cube minus x squared plus 1, then find the value of 1 plus alpha by 1 minus alpha plus 1 plus beta by 1 minus beta plus 1 plus gamma by 1 minus gamma. Now, in this equation again you may now be tempted to write down the sum of the roots, all those three relations of this equation, and then you just expand it and hope that you can quickly get the value of this. Instead, I'll try to show you a different method, which is mathematically a very completely sound and technically correct method. At the same time, it's a much easier method. Okay, so since for this equation, you see the roots are just transformed to 1 plus alpha by 1 minus alpha, right? You see all of them are symmetrically transformed. So what I do is, I just put a new variable and I write that as 1 plus x by 1 minus x. Right? So you see that if alpha, beta and gamma are nothing but three different values of x for this function, right? So what I do is, I transform that variable to a different one, to specifically actually 1 plus x by 1 minus x, so as to suit my values here. Now, since I am supposed to find out the sum of the roots, I'll just put back I'll find my new equation and find the sum of the roots from that. Right? So this gives me y minus xy is equal to 1 plus x, or y minus 1 is equal to x times 1 plus y. That gives me x is equal to y minus 1 by y plus 1. Okay, so let's substitute this back in the original equation. That gives me y minus 1 by y plus 1 cube minus y minus 1 by y plus 1 squared minus 1 equal to 0. Okay, so that gives y minus 1 cube minus y minus 1 squared into y plus 1 minus y plus 1 cube equal to 0. So let's expand all of them now. We have y cube minus 3y square plus 3y minus 1 minus y squared minus 2y plus 1 into y plus 1 minus y cube minus 3y squared minus 3y minus 1 equal to 0. Right, so y cube and 3y, these two cancel out here, and the other terms actually add up. So we have minus 6y squared minus 2, and here we have, let's expand this now. So y gives us y cube plus 2y squared minus y squared plus 2y minus 1 equal to 0. Right? So I have minus y cube, the first term, and then for y squared I have minus 6y squared plus 2y squared minus y squared. That gives me minus 5y squared. Then I have minus y plus 2y. So I have minus y plus 2, that's y. And then I have minus 2 minus 1, so minus 3. Right? So just multiply the whole thing with the minus 1. So I have y cube plus 5y squared minus y plus 3 equal to 0. Right? So I see that I obtain a new equation which will have the roots 1 plus alpha 1 minus alpha, 1 plus beta by 1 minus beta, and 1 plus gamma by 1 minus gamma. These are the roots of this equation. And now I am supposed to find out the sum of these three terms. Hence, my answer will be sum is equal to minus 5. Right? So we see that we cleverly transform our variable x into a new one so as to find the new roots, and hence the relation between them can now easily be found out to be minus 5. So this concludes our video series on quadratic equation expressions. Stay tuned for further videos. Thank you.